Welcome back. So, in previous lecture we were talking about that what will happen if we put the tunnels perpendicular to the fold axis. Okay. So, as I explained in the previous one that we will come across number of formations or the number of beds of the different rocks which is not ideal, because they will have different shear strength, they will have different compactness and all that, and we will require multiple treatment if you are coming across different type of rocks. Okay. So, and again and in terms of the syncline or anticline, this is not advisable at all. Okay. Because tunneling perpendicular to the fold axis is not at all advisable or desirable, because different rock formations which we will encounter from place to place, okay, and that will have different shear strength and all that. Okay. So, it is not advisable at all to put. So, only best is that if you are identifying a thicker bed, okay, or the thicker limb, that can be taken into consideration, and it is most ideal to put the tunnel there. Now, effect of joints, again as we were talking about that in the folded regions we will normally come across the joints, okay, but how far they are extending, that is extremely important. And so, mostly the joints of the fractures are the weak zones, okay, which will reduce the shear strength of any rocks. Okay. So, some joints are superficial and disappear with depth, okay, they will not extend to the greater depth. So, this should be okay, properly studied. Okay. Close space joints in all kinds of rocks are harmful. Okay. So, we have to talk about the spacing of the joints, we have to talk about that how long the joint goes, okay, that in terms of the surface extent, okay, and also we talk about that how deep these joints will be. Okay. So, for example, in Koina tunnel which was excavated through the compact basalt, okay, within closely spaced joints, okay, this caused problems. Okay. So, constant roof faults will be there, heavy leakage of the water, etc., which made tunneling process a very expensive project, okay, and it was a difficult task. So, importance of the orientation of the joint is extremely important. Dip and strike, that is the attitude, and this is important for all, like folds, joints or faults. Okay, this we need to know. Okay, so very important in terms of like respect to the tunnel alignments, because that will help us that how the tunnel should be aligned. Okay, and joints which strike parallel to the tunnel axis will persist for longer distance. Okay. So, if you are having the strike of the joints which are parallel to the fold axis or tunnel, they will for the longer distance they will see. Okay. So, that will be that we need to take care of. Okay. Hence, it is undesirable in all kinds of rocks. Okay. So, joint striking oblique or perpendicular to the tunnel axis, okay, or the fold axis we are taking, okay, will be for the limited period, okay, like limited area it will be covered, otherwise we will have. Okay. So, this one has to take into consideration. Okay. Now, faults at the tunnel side, again this is what it has been shown. So, in the previous what we were talking about, that if you are having the joints which are parallel to the tunnels, okay, or the tunnel axis or the fold axis, okay, then it will persist for this, but not in most cases we will be able to see that. Okay. And then if the fault is of course on the surface it is away, but here we have the fault print which is causing the tunnel, it is not advisable. Okay. And but in some places if you are having the at few locations where the fault is passed, this could be a good site. Okay. So, in civil engineering projects the faults are harmful and undesirable because of the following reasons, because the active fault zones are the locations where there is a scope of further or future recurring of the earthquake. Okay. So, it is the most likely place which will be the source for the large magnitude earthquake in near future. Okay. So, irrespective of the attitude of the tunnels, okay, that is the alignment, okay, okay, this should be avoided. Even areas of inactive faults are the places of intense fracturing and shear zones will be there. So, hence those requires proper lining, and which can in sense increase the project cost. Okay. Just an example here, suppose we are having we are laying the road at the edge of the folded structure, and if we come across the beddings which are dipping towards the road, okay, and another location is that this is unsafe, but another location where we are having the beds which are dipping in the opposite direction from the road, okay, these are the safer places to be done. And of course, nowadays we have like putting the concrete covers and all that, okay, to avoid the landslip here, okay, but these are the dangerous locations if we are not properly taking into consideration the dip and or the attitude of the rocks. Okay. So, I will end here, and I will start with a new topic that is on tsunamis. Okay. So, let us move to the new topic. So, we talked about the faults, folds and all that. Now, this is another very important aspect which we should learn. We should understand the process, and we should also know the areas which are vulnerable or are at risk from this type of hazard. This is tsunami. Okay. And in this event jottled the Indian subcontinent and the neighboring areas which are adjoining the Indian Ocean during 2004 Sumatra Andaman tsunami. Okay. And we were not very much prepared about such events, and because of lack of understanding, because of lack of historical documents and all that. But of course, now the studies suggest clearly that that was not the only event which occurred in this region, but in the past we have similar giant tsunamis triggered by mega subduction zone earthquakes in that particular region, that is Sumatra Andaman subduction zone. Okay. So, let us talk about the tsunami, what exactly it means and how it has been triggered. Okay. So, tsunami words come from the Japanese literature, and it means the harbor wave. Okay. And height of this wave is small and barely noticeable in deep ocean, because the wavelength will be very high, very large wavelengths, and the height will not be able to see. Okay, because the height of this wave is very small and barely noticeable in the deep ocean, okay, but becomes larger and damaging when it approaches the coast. Okay, because as it approaches the coast, it will stack up, all the waves will stack up and result into the almost like a sea wall. Okay, and that what was been experienced in 2004 Sumatra Andaman earthquake, and similar things were been experienced in 2011 Tohoku earthquake in Japan. Okay. So, what they say is a big wave. Okay. So, wave will be extremely larger, will develop and then because of the stacking. Okay. So, in ocean it will be barely noticeable, and this was also when experienced by the fishermen. Okay. And the boats which were sailing at that time in the Indian Ocean, they were not affected at all by that tsunami, but when they reached the coast, they found that there was huge damage, and that was resulted because of the deadly tsunami. So, this what usually happens. Okay. So, this is the cartoon which shows the oceanic plate, okay, subducting below the continental plate here. It can be a combination of oceanic and the continent here, that should not be any problem. Now, when this keep on moving, okay, there is a strain which is developing here. So, this part is locked actually, this part is locked over here, and then finally it will release the pressure, okay, and that will be an earthquake. And because of the sudden displacement of the water here, you will experience a tsunami. Okay. And that what has been shown here. I will play it again and you please carefully watch this. Okay. So, you are having in you have a locking here at this place and this area got uplifted. Okay. When this plate was moving down, this area got up. So, you will see that also, or it may subside also. Okay. This may subside and then it was been released. So, there will be the water column was been displaced here, and then at the same time you will also have the land level change, because this island, the land the level of this island got changed. Okay. So, this let us see again. Okay. So, what it has been shown here, that this area got uplifted. Okay. This area got uplifted and then you had a massive tsunami here. Okay. So, this what happens. Now, this is an example of the Chilean earthquake. This was one of the largest earthquakes so far recorded in the history of Earth. Okay. We do not know about the past. Okay. But this was the largest one until recorded. Okay. 9.5 Chilean earthquake of 1960. And if you see this graph here, it shows that the arrival time of the tsunami. Okay. This is a tidal chart, tidal curve. Okay. We are getting. Okay. So, the tidal graph shows the sudden change in the amplitude of the over here. Okay. So, this is what you see, the rise in the amplitude. The maximum amplitude goes up and then, so this is the normal curve of that. Okay. So, estimated up and down, up and down. This is the average of the tsunami tidal curve. Okay. So, high tide, low tide, high tide, low tide, but here what you see is the massive change which was been noticed at that time. Okay. So, long water waves generated by sudden displacement of underwater. So, this displacement was along the plate boundaries. So, we have the long wave which will be generated. Tsunamis are called as seismic waves. Okay. Are series of waves generated by large violent earthquakes occurring in the ocean. Okay. Now, this is not always like there is an experience, or tsunami can be generated in any water body because of the sudden displacement of the water column. Okay. That is possible. So, if you are having a meteoritic impact also, that can happen, that can result into the tsunami and maybe much more violent tsunami. And then submarine landslides can also trigger tsunamis. Okay. Because it will result into the disturbance on the water column on sitting on the top of that. So, sudden displacement underwater, that is in the sea or anywhere in the huge reservoirs, will result into the formation of the tsunami. That is a seismic sea water wave. Okay. We are having the sea wave. Or so, not all earthquakes generate tsunamis. Okay. Not necessarily, because if there is a less displacement and less displacement of the water column, it will not trigger the tsunami. Maybe the tsunami will go unnoticeable. Okay. But most of the destructive tsunamis are generated from large shallow earthquakes. Okay. So, if the earthquake's energy is released at the shallow depth, then that will result into the tsunamis. Okay. So, normal sea waves and the tsunami waves, if you compare that, okay, then what you will be able to see is the normal sea waves and the tsunami waves wavelength ranges up to 1 mile or 1.16 kilometers. Okay. Whereas here, in terms of the tsunamis, the wavelength can range up to hundreds of meters. Okay, or hundreds of kilometers. It can range into that. Okay. So, around a kilometer, but here you are having more hundreds of kilometers. Okay. Few miles an hour, up to 60 miles an hour it can travel, but here it can travel at very high speed. Okay, or very velocity is almost like a jet plane, okay, 800 kilometers per hour. Okay. So, it travels very fast, the velocity is very high. These are generated because of the gravitational attraction of the sun, moon and sun, but these are generated by earthquakes. Okay. The mega tsunamis are always triggered by earthquakes. Okay. So, these are the major difference between the two. The normal sea waves, the wavelength ranges for few kilometers, whereas the wavelength ranges for hundreds of kilometers. Okay. And the few miles, the velocity is not so high. Okay. But here the velocity goes around 800 kilometers or more, okay, per hour. Okay. And these are mainly because of the attraction between the sun and moon, but here we are having mostly because of the earthquake. And as I mentioned that other than the earthquakes, the other sources for triggering earthquakes are the submarine landslides, and we are having meteoritic impact. Okay. So, those are the other things which we are having. Now, tsunami is usually not the first wave can be the most powerful one. Okay. And in most of the cases this was been noticed, okay, that not the first wave was very powerful. So, people thought that okay, nothing will happen, but the second wave or the third wave was massive and destructive. Okay. The duration of the wave action is as long as several minutes, okay, to around 10 minutes or longer. So, that depends on the that what is the wavelength and all that. Okay. Depending on that, you will have the difference between the two waves, okay, which are coming. Okay. Narrowed bay produces high tide levels of tsunami. Okay. So, if you are having this, so this here the important comes of that what is the configuration of your coastlines. Okay. So, if you are having different like open coastline, then the effect will be different. If you are having narrow coastline, then the effect will be different of the tsunami. If you are having rocky coastline, then the effect will be different. Okay. Hits as fast as the aircraft or the bullet train. Okay. So, it is more than that. Okay. The fastest bullet train might be around 350 kilometers or so, or maybe faster than that, but aircraft is around 800 to 900 kilometers per hour, jet planes mostly. Okay. So, it has tremendous speed. Okay. Now, why tsunami so destructive? Okay. This is what we were talking about, that in ocean, okay, the wavelength will be too large and the height will be too less. Okay. So, large wavelength, less height in the deeper part of the ocean, but as it becomes shallower and shallower, okay, it reduces the wavelength and the height increases. Okay. So, reduction in the wavelength, height increases, and then stacking up of this waves will result into the giant tsunamis. Okay. This will result into the giant tsunami. So, that is what the difference we will see. Okay. So, as the tsunami enters the shallow waters near the coast, its velocity decreases, but the height, okay, velocity decreases, the wavelength decreases, okay, but the height increases. Okay. So, if when it enters the shallow waters, the height will increase. Okay. That is extremely dangerous. Okay. So, crust heights more than 30 to 50 meters have been reported in some places. Okay. So, this is one of the reason for that, why it is so destructive in terms of when it reaches the coast. Okay. Otherwise, it is barely noticeable in the ocean. So, height and run up of the tsunamis are extremely important, and this usually we measured the heights and run ups. Okay. Height of the run up height of the tsunamis after the event, because this record is extremely important and can be used for modeling purposes and can be used to generate the tsunami hazard maps. Okay. Because this information has to be passed on to the administration, okay, which can say that okay, fine, these areas are not safe and you need to move to the higher grounds when there is a tsunami warning, if it is issued, if at all it is issued. So, height or the run up of the tsunami at the point of impact will depend on, okay, this is again it will change, okay, like it depends on how the energy is focused, from where the water is coming in, okay, that is important, and then your location and the travel depth of the water. Either your location is very, you are having shallow shelf or you are having a deeper one, okay, or inclined one. Coastal geomorphology is extremely important, that is of offshore topography. Okay. Tsunami run up is the vertical distance between the maximum height of the water reached onshore and the mean sea level surface at the time of the event. Okay. So, the difference you are taking actually, okay, the difference between these two. So, the time of the sea level at the during the event, and then you are having the that how far it reached. Okay. So, that level difference you will take. Okay. Let us see another in another slide how we have taken into consideration. Okay, this one, yeah. So, here it explains that you are having the this blue one, this is the sea level you are having, okay, and A, what you see is the measured height. Okay. So, the measured height at the time of the event, okay, and then B is your this one, the difference, that is the tidal difference between the time at the time of the tsunami and at the time of the measurement you are taking into consideration. Okay. So, you are having this difference, you are having this difference, this will give you the addition will give you the tsunami height, okay, because you are taking the height from here, the extreme end up to what where it reached, okay, and then this can be taken up after the tsunami. We see that then how far the tsunami debris were been transported, and then how this watermarks on either building or any other structures we will see, because there will be in some residence time of the water which will remain here, which will result into the development of the watermark, and then the bend of the twins, because when the water comes in it will try to break the twins and all that, or the small branches, that can also be taken into consideration. And then wounded trees, okay, tree can be, if at all they are alive and they are standing, okay, otherwise most of the trees will be uprooted. So, if we find such wounded trees and the bent twigs, watermarks and debris, that helps us in putting the final height of the tsunami run ups. Okay. So, this helps us in talking about that, okay, fine, if this magnitude earthquake occurs in near future, this areas will be getting inundated. Okay. So, this is extremely important for us to mark the run up heights, okay, after every events. Okay. So, this is the difference between that. The C is the addition of what we are having, this is the tsunami, the height of the sea level at the time of the measurements what has been done, okay, and then finally we will come across the height C. Okay. You can also talk about, you can calculate the energy, okay, for the tsunami, okay, with this equation, okay, where E T is the total energy, how much energy will be released. Okay, we will stop here and then we will continue in the next lecture.